Our next chapter there is similarity and enlargement. Now, similarity and enlargement is a bit wide. So it has lots of applications. So here the competence is the learner understands and applies relationship between length, area, volumes of similar shape, and objects. So here define enlargement, understand the use of relationship between linear, area, volume, scale factor, and so on. So here we are going to focus here. Our focus was on how you can enlarge an object using a negative scale factor, but there are many using linear scale factors, volume scale factors in this chapter. So here, we had a square of at 1, 1. So our first square was at 1, 1, which is there, the first vertex. Then the other one was at 2, 1. Then we had 1, 2, and then 2, 2. So that was our square. So this square was given an enlargement about the origin. So we first create that shape, bring it out there. Okay, so that's our square. Now, about enlargement, you can visit the playlist and see different scenarios about enlargement. But here specifically, whenever they give you a negative scale factor, it means that now the object was reflected to the other opposite side of the center of enlargement. Now, they gave us the origin as the center of enlargement. What we do first is we get and we join all the vertices through the center of enlargement, which is now the origin in this case. So you come, you join that in that order. You also join this. Then you also join the second, the third one, third vertex. Then the last one, which is this one, to the center of enlargement. So there, you also join it in that order. Those lines should be long enough. So the next thing is, now this is the interesting part. What we do, the center of enlargement is to meaning that the distance now, the object distance from the center of enlargement is the image distance going to be twice the object distance from the center of enlargement, meaning the distance from here up to here is going to be multiplied 2 times to get the distance of the image to the object, but following our lines we drew already. So let me start with this one. So this one, you see the distance there is this. So by this distance, to get now the image, I have to get this distance twice, but following this line, so I press at the center of enlargement like this, press my first there, that is 1. It has to be twice because of the 2. Then the second one is there. So where it falls, now this one becomes my first coordinate there of the image. For this one now, remember this one here. Maybe to avoid problems, let me just call this one A, B, C, and this other can follow properly. Now this is now the B prime, the image. Now I come to the one for D. D, I measure this distance from here up to here. Then I take that distance and I measure it 2 times from the center of enlargement, then 2 times 1. Then from here I also come and I get the second one, 2. So now this is going to be, that's where now my D prime is D prime. Then I come now to A. My A was from there up to here. So now I'm going to from there. So then I follow the one for A. A is here, going here up to here. That's where my A is. So my A, so this is my A, it was coming from there, it comes up to here. So that was my A. So from here I measure 2 times 2, then also here I measure 2. Why are we measuring, why are we going in the opposite direction? Because whenever we have, remember, our scale factor is negative. This one means that it's going to be on the opposite, or it's going to be reflected by the center of enlargement. So our center of enlargement is here. So because of this negative, it's reflected the other opposite side. If it was positive, then it would have gone the other side. But because of this negative, it's reflected. But this too means that the distance from the center to the object is going to be now, to get that of the image is going to be now twice. That's why if it was 3, then we would have measured 3 times. And I come to my C, I measure still C. Then I come inside and I measure C. My C will be the first one, will be there. Then my second will be there. So now this will be my C prime. Then after that, I can ably join these 4. So join that to that, join this to this, then also this one here. So now from here, you see that we say that when you are enlarging, if it's not 1, then the size always is bigger, but the shape is maintained in enlargement. I mean in enlargement, the shape is maintained. So now to get the new coordinates, because they wanted us to get the new coordinates, now our A prime, I'm using this one so that I can to easily for us to follow properly. So our A prime is -2, -2, -2, -2. Then our B prime, our B prime is -4, -2, -4, -2. Then C prime, so that our C prime is -4, -4. Then our D prime, our D is where? Our D is here, -2, -4. -2, -4. So those are the new coordinates. I introduced in A, B, and C so that we can easily follow. And it told us that help the student determine the new coordinates of the square alpha transformations and explain how the negative scale factor affects the size. Now, because we have a negative scale factor, first of all, the image and the object are going to be on opposite sides of the center of enlargement, and because it's a 2, then the image is going to be twice the size of the object. So those ones you can put them, because you have to respond, so you respond that to that scenario in that order. So that's how we do. But if you want to see many, please go to the playlist, then see more of them. Sit. I can't fail. Come closer. I'm going in case I fail. Chop, 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 chop. Chop, 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 chop. What he thinks. If it was him. Kaya lero somaku. I will go for the ABC. You see the regular. Huh. Let's move with it. What's rotation? Rotation, move. Move. Rotation. Okay. It's kind of simple. It's kind of simple. Just tell me. Yes, not so simple. Not that simple. In the middle. Wow.